Or they could also give us the arrow markings. That tells us that they're parallel. Or again, as we've seen before, instead of again telling us in words, they can say off to the side, A is parallel to B using that notation style. Okay, so we've got these two lines are parallel. Now what do I mean by a transversal? What a transversal is, I can spell it, Transversal. Transversal. Okay, a transversal here is a line that comes in and intersects more than one line. Okay, so that line T, as it comes in here, this line T is intersecting lines A and B, and therefore we call line T is called our transversal. So that's what we say parallel lines transversals. That line T is called our transversal. A and B, there are parallel lines. T is called our transversal. So when line T comes in here, all right, when line T comes in, what it starts to do is create a bunch of angles. So on these two lines that we have, A and B, and line T comes in, what we have always being created is 8 angles. Okay, that's always going to happen. Now, when those 8 angles are being created, we have some angle relationships that start to happen. All right, and around this picture here, we have some angle relations happening. Let's see what you guys remember about that. Now, most recently, we've been talking about 2 of these relationships. Let's start down at the bottom. Those are most recent ones, okay? So vertical angles. Let's go with the most recent ones. So we have these 8 angles happening. What do we know then, again, about vertical angles? Vertical angles are always what? Always congruent, right? Vertical angles, those are happening when 2 lines intersect, right? So vertical angles are always going to be congruent. Now, with these vertical angles being congruent, somebody, give me an angle pair up there. Patrick, don't need to be working on that. You need to be focused on your notes, bud. Okay, vertical angles are going to be congruent. Give me a pair of angles there that are considered to be vertical. Brianna? Oh, okay. 6 and what? 7. 6 and 7. Okay, 6 and 7 are a pair of vertical angles. What's another pair of verticals?
1 and 4.
1 and 4. What's another pair? 2 and what?
3.
2 and 3. And what's my other pair? 8 and 5. Okay. Now, all those that you rattled off only required how many lines? Just 2, right? It required, when you said what? 5 and 8. 5 and 8 only required what 2 lines? 5 required B and the transversal, right? It didn't have anything to do with line A. Again, vertical lines only require 2 lines, right? Okay, linear pairs. Linear pairs, what do we know about linear pairs? Linear pairs are what? Adjacent and, keyword is, supplementary. Yes, they're adjacent. We're talking about the measures here, so we're going to say big one is supplementary. Okay, so they're adjacent and big one is supplementary. We're really talking about the measures here today with them. Okay, so again, we talked about this over the last couple days, that when these with our angle vocabulary, okay, that we talked about a linear pair. Now in a linear pair, we got a bunch of those up here, just like verticals. Somebody give me an example of a linear pair up there. 1 and 3. A linear pair is adjacent and supplementary. 1 and 3 is considered to be a linear pair. Using 1 again, what's my other linear pair with 1? 1 and 2. So Eva first stated 1 and 3 is a linear pair, but there's another linear pair with 1. We could have gone to the right and said 1 and 2. So there's a bunch of linear pairs happening up here. Okay, give me another option of a linear pair up there, Brianna. 2 and 4. There's another linear pair, more than 1 up here. What's another linear pair? 3 and 4, right. Or we could drop down to the bottom. We can walk around the bottom and give me what? Yeah, 7 and 5, 7 and 8, 6 and 8, right? Those are all considered to be linear pairs, right? There's a whole bunch of options for a linear pair. I'm not going to list them all out. There's a bunch of those. Now, those are our most recent ones. Those are the ones that we've been talking about here lately. What, again, I want you to keep emphasizing is, one, how do you identify them? And two, what do we know about their measures? Now, when we talked about linear pair just now with, we start off with 1 and 3, 1 and 2. Again, 1 and 3, 1 and 2 only required how many lines? 2 lines. Only required line A and line T. But as we're about to go up above now to get the other 5 angle relationships, those are going to bring in all 3 lines now. Okay. Now let's see what you guys remember about parallel lines and transversals and these 5. Hopefully these kind of ring a bell. Come on, Race. Hopefully these kind of ring a bell from what you guys remembered from previous years. We'll find out. All right. Now, I would think, I've done this quite a few years, some of these name kind of almost give it away. Almost. So let's go through, let's do a few of these together just by looking at the name of it. Let's just start right here. Okay, we're going to start this first one we call same side interiors. All right, first off, the interior, which angles would you say are considered to be interior angles? You have to. Yeah, so what angles are considered interior angles then? 3, 5, 4, 6. Exactly. Those are interior angles. They're in between lines A and B. The other 4, 1, 2, 7, 8, those are exteriors. Duh. I think that hopefully makes sense to you, right? Now, let's bring in the next piece of that. The same side. Same side of what? Line T, the transversal. Exactly. It's the same side, the transversal. So first thing is the interior narrowed it down to those 4. The same side is referring to the same side of the transversal. So when we bring those 2 things together, okay, you have to finish this off. What would be considered then a pair of same side interiors?
3 and 5.
There you go. Okay, 3 and 5 is a pair together, and then the other pair is 4 and 6. That's my only options there. There are no other ones, 3 and 5 or 4 and 6. Now, if we were to get our compass out, not compass, protractor out, if we were to get a protractor out, measure angle 3, measure angle 5, and we were to look at our protractor measures now, what we would find there's a relationship there. They're not going to be equal. There's one instance where that happens. But there is another relationship there that happens, and the relationship that's there is they will always turn out to be supplementary. Okay? The same side interior measures will always turn out to be supplementary. So if we were to measure out angle 3 and angle 5, angle 3 turns out to maybe be like 100 degrees. Maybe angle 5, then angle 5 will turn out to be 80. They will always be supplementary. Maybe angle 3 turns out to be 110, angle 5 is 70. They will always be in that relationship every single time. Now, that same side interiors. All right, let's go next door. Let's use our context clues there. Same side exteriors. Deontay set it all up for us. We're all smart kids. What would be an example then on Carter of the same side exterior?
1 and 7.
1 and 7. We already narrowed out to the exteriors, 1, 2, 7, 8. Same side means of the transversal. So Carter suggested 1 and 7. Totally makes sense. Okay, use the description there. 1 and 7 is, and my other pair is 2 and 8. Absolutely correct. Okay, and same thing. Same sides, interiors or exteriors. It's going to be that same relationship. If we measured them out, they're not going to be congruent. There's one exception to that rule, but that other rule would also turn out to be supplementary. Same sides are always turn out to be supplementary. Okay. All right. Let's keep using the description there to help us out. Let's go up to alternate interiors. Okay, Deontay already knocked out the interiors. So let's go back to the interiors. 3, 4, 5, and 6. We're right there. Now, for the alternate part, alternate to what? Still a transversal, correct. We're still alternate to the transversal. So alternate interior. Somebody give me an example of then what would be considered an alternate interior. Yeah? Okay, I got Kate in here. What did you say now?
7 and 2.
Oh, we're on the interiors.
Oh, shoot.
You're cool. So what did you say then?
3 and 6.
3 and 6. Okay. So Caden's suggesting 3 and 6. Anybody else another suggestion on instead of 3 and 6? 4 and 5. Cool. You out there? Were you gonna say anything else? No, you're cool. Okay. Now I'm gonna play devil's advocate because that's just what I do. I'm gonna throw out the 3 and 6. I'm gonna throw out another option. I'm gonna throw out 3 and 4. Now don't put that down yet. 3 and 6, 3 and 4. I'm playing dumb here. I know it's not play. 3 and 6, 3 and 4. Doesn't that kind of both make sense? They're both alternates of the transversal, right? They're both interiors, right? So somebody want to make a better argument of why one's working one instead of the other, Carter?
I think 3 and 4 works better because it's similar.
Okay. Somebody else want to throw this? I saw another hand up. You're gonna say? Anything else somebody want to throw out there? I'm just gonna tell you my 3 and 4 is not correct. We've already taken care of 3 and 4. Where have we taken care of 3 and 4 already? Caden's totally correct. Where have we taken care of 3 and 4? Linear pair. What are 3 and 4? They're also adjacent. Where are adjacents taken care of already? Down here at a linear pair. So on the alternates, the one small catch is, and Caden was correct with this 3 and 6, and what was the other one? 4 and 5. That is correct. Alternate interiors, that is absolutely correct. I'm going to just throw in one little bitty thing here. Make sure you are never adjacent. Okay? So I always have a handful. I want to throw that in there, but we've already taken care of those adjacents, haven't we? Those are linear pairs. Now, when we look at 3 and 6, we got our protractor out, we measured 3, we measured 6. We're going to find out they always are going to be congruent. Okay? If we were to measure those, they are always going to turn out to be congruent. The alternates are going to be congruent. 4 and 5, we measured out 4, we measured out 5. They're going to be in a relationship, they're going to be congruent. They might turn out to be supplementary, but there's only one instance where that happens. Only one single instance that happens. They'll still be congruent, but there'll be only one example where that happens. So we just say they're always congruent. Alternate interiors. Caden, you said a second ago already for the alternate exteriors. What was the alternate exterior example you gave me, Caden? 7 and 2. And what's the other pair? 1 and 8. Again, what's the catch? Not adjacent. Correct. Because we've already taken care of the adjacent part of things. If you want to tell me 1 and 2, which is kind of almost correct, but 1 and 2, we've taken care of that. Where have we taken care of 1 and 2? That's a linear pair. Those are adjacent to one another. Okay. Again, we measured out 2 and we measured out 7. We're going to find out that they are congruent. Okay. All right. The last one that I think does not actually do a good job of kind of explaining itself in words of where they're located is corresponding. Okay. So corresponding angles, think about it in the same relative position. Okay, in that same kind of relative corresponding position. So what do I mean by that? They got to be on the same side of the transversal. All right, I'm going to jot that down. Same side of transversal. That's got to be true. So that same kind of relative position. So same side of transversal. And then what you're also going to find is one is always going to be interior and the other one's always going to be exterior. One interior and one exterior. And when you throw that in there, and we've said we've already taken care of adjacents because linear pairs we've taken care of, that kind of already throws in there. So with that in mind, Carter, can you give me an example of correspondence?
2 and 6.
There we go. Okay. So with that kind of then description happening now, same relative position, same side of the transversal, one interior and exterior. We're not throwing in adjacents because we've taken care of adjacents down here. What that leads us to then is same side of the transversals, one interior, one exterior. Now it could be 2 and 4, but we've taken care of 2 and 4 in linear pairs. Yes, 2 and what'd you say, 6? And what's my other pair that's on the same side there? 4 and 8. Again, when I say kind of same relative position, when I look at 4 and 8, aren't they kind of both below those two parallel lines? That's why I mean like the same kind of relative position. Same side of the transversal, both below. How about the other side? What's my correspondings there? And there you go. We're good. Hopefully, I'm hoping that jogged some memories. Did that jog memories? Yes or no? Let's go with no. Did that not jog any memories? Okay. So have we never seen parallel lines and transversals? Okay, that's okay. Never saw parallel lines and transversals? Okay. All right. Now, if we were to measure those, with our protractors, what we would find out is they are also going to be congruent. Okay. Now, I say parallel lines and transversals. These angle relationships can happen when they're not parallel. Okay. We could have two lines like that. I did a good job there with that. These are not parallel. They're eventually going to intersect, and I can throw in a transversal. We still get the same 8 angles. The only difference is these congruents and supplementaries are not happening. Okay, we can still say we have alternate interiors and same side interiors. It's just that we can't say that they're going to be supplementary or congruent. But everything usually happens with these angles when they turn out to be parallel. So everything we're going to do in here turns out to be working with parallel lines and transversals, and these are always going to be congruent and supplementary when they are parallel and when these lines are parallel. Okay. Now, the other thing here is before we flip it, lots of our times I keep saying same side interiors. Don't be surprised if you come around the word consecutive. Depending on what book we use sometimes, or if you Google something, they can be used interchangeably. Consecutive and same sides mean the same thing, just as a heads up. All right, let's flip it. Let's do a little practice then here. Actually, I gotta load up the next page. So let's go. Let's do a little practice now with that little kind of graphic organizer we just put together. Excuse me. That's what we're using here. Let me see, make sure I get the right page loaded up on the notes. Part 2. All right. So what I want you to do then is take number 1 when I get mine loaded up. Take the description that's happening there, number 1, label it out. Based off what we just talked about, go label it out, everybody. Okay? Take what we just got. See about you labeling out, and if you haven't got your calculators out, you're definitely going to need the calculators. Okay? So go ahead and label it out based off number 1. Let's do some work here today, guys. And that graphic organizers might be your buddy, especially if you've never seen that work before. Okay? Especially if you've never seen that work before. Let's make sure you have that out there. Making sure you're today doing that delta math. Take a second, label out number 1 based off what we just talked about. So again, it's all about that vocab. All about that vocabulary, and then we're going to apply it afterwards. And we're going to be setting up some equations here, solving it out based off of, again, knowing that vocabulary. Alrighty. we'll label that out. Lines A, B, cut by transversal T. Do I care which one A and B is? No. But T, yes. T's got to be the transversal, so that does matter. The A and B does not. All right, let's do this. 3. Now, don't write this down yet. I'm going to call this X, Y, Z, and T. That's a bad word to use T because I use T. So let's call that OH. All right, somebody. Which one's going to get 8 on there? X, Y, Z, or H? H, 3, and 8 are corresponding. That makes sense. Same relative position. So below, there we go. 4 and 5 are same side interiors. Where's 5 going? Sounds good. 4 and 5 are interiors. Makes sense in between and on the same side. 2 and 7 are alternate exteriors. Z. Alternate exteriors. Exteriors on the outside. Alternates on the opposite, different sides of the transversal. And of course not adjacent. And what we just say is that 7. And of course process elimination. Let's make sure it does fit right there. 7 and 6 are going to be vertical. Does that seem to fit then? Yes, it does. Okay. So again, using that vocabulary with that. Using that vocabulary now with maybe that calculator if we need to. All right. Kind of like what we've done the last couple days with angles in general. All right. I'm going to put a minute on my clock. I want you to go through those next 3 and do whatever you need to. Find me those missing angle measures there. 1, 2, 3, 4, however many are there. Using that vocabulary from the last few days, couple days, and then today. What do we know about those angle positions? Are those alternate interiors? Are they congruent? Are they same side interiors? Are they going to be supplementary? Are they vertical? Roto or verticals? All right. Whatever you need to do, it's like a puzzle. I'll shut up now. Go. It's helpful if you can rip that thing out like we scratch it back and forth on. Feel free to. Check graphic organizer. It's helpful for you. Please rip it out. All right, let's take a look at that first one there. So using whatever you need to, okay? Now some of these, it's going to be quicker and easy to use it vertical angles or a linear pair. Those are a lot of our go-tos. And now also, we're bringing in our graphic organizer from a few minutes ago. Okay, alternates, interiors, exteriors, same sides, or correspondings. Now, there is not a roadmap. You got to go this route. It depends on how you see it. Okay. So on that first one, angle 2 is probably the quick one. Angle 2 is what? 100. It's vertical, isn't it? Okay. Angle 2 is a vertical angle. It's 100 degrees. Now after that, somebody, what's angle 1? Angle 1 is 100. Now why is angle 1 turn out to be 100? Because right here, what we have then is alternate interiors. We have alternate interiors right here, and what do we tag that as on our organizer? They are congruent. Okay, you got to know that. So again, this is where we're talking about if you've not had a ton of exposure or just practice with it over the years, it's going to show pretty quickly here. Okay, so alternate interiors are congruent, 100 degrees. All right, let's go next door. Only thing we know is 85. Okay, for me, quick one is angle 2. It's right next door. It's adjacent to it. It's a linear pair. And what do we say about linear pairs? They're supplementary. So again, going back to that other vocabulary, that angle vocabulary should be over the years' time. Not just you saw it, but you've been using it since 5th grade, 6th grade, 7th grade, 8th grade. You're comfortable with it. You're seeing it immediately. Okay, 180 minus 85. Angle 2 is what now to start off with? 95. starts it off. We get another pair of alternate interiors in there. Okay, going back to that 85, just like we did back here. For me, I see 85 and angle 1. 85 and angle 1 are another pair of alternate interiors. They're interior, they're on different sides of that transversal. So 85 is, or angle 1 is, I should say, 85. We can do same side interiors. 85 and angle 4. These are same side interiors. And what do we say about same side interiors? Supplementary. So supplementary, 180 minus 85 is a 95 right there. Did I have to do that route? No. I could have done another alternate interiors right here. I could have done a linear pair right there. There's more than one way to do all these. Angle 3. What's somebody have for angle 3? 85. For myself, I see correspondings right here. 85 and angle 3, they're in the same relative position. They're both on the same side and left of the two lines. And what do we say about correspondings? We tagged it as congruence, right? So 85, 85. Or heard somebody say vertical angles right here. Those are all correct. And this is where, again, it comes from practice and practice and practice. Perfect practice makes perfect. Okay, letter C. One right off the bat should be angle 3. That's my verticals. Angle 3 is 135. Now after that, you're going to have to do some of our new ones, because everything else is on that next group. You're going to have to do some type of carryover with one of our 5 relationships from today. Whatever you want to do, I don't care. What's angle 1 going to be? 135. Yeah, it's a corresponding angles. Same relative position, 135, congruent. Now that you've carried yourself on down there, once you get into that group of 4 right there, you can always walk it around and do what? Verticals and linear pairs right around there once you get one of those. Or I got myself a same side interiors here. I could have carried it down with the same side interiors. What is 180 minus 135 give me? 45. And once I get that 45, I can walk it around and do, again, verticals and linear pairs. What you should see then is some type of supplementary relationship happening between your two numbers down there. And after that, angle 2 is correct, 135. Again, however you see it is going to be different than how I see it. It's going to be different than your buddy sees it. As long as you're getting the same answers, you should be good. As long as you're not looking off of buddy's answers too. All right, let's do it again. Let's create an equation off of it. Number 3. Just like we've been doing the last couple days with angles, still using angles, but with parallel lines. What do you see on letter A? What relationship is there? And what that relationship is there, is it congruent or supplementary, Yante? Okay, almost there. Not complementary. Get that different word stuck in your head there. There you go. Yeah, we got a lot of different words there. Yeah, that's corresponding. He's correct himself, but he did say though correctly, congruent. So in that same relative position, they are corresponding angles. And again, if this is your first time through, or even not even your first time through, but you just are not had a ton of practice with it, I would write that down. Corresponding angles, and what did you say? They are congruent. More times you write it down, it gets better. If you don't, it's not going to get as good quickly. Set up the equation, because he said it's congruent. And then let's go at it. Okay? We're done with geometry. The rest of this is algebra. X is on both sides. I like to always move a smaller x myself. I'm going to subtract 2x. Do I need to show minusing 2x? No. You should again be aware of how to solve out simple equations. If you're having issues with seeing those equations, you better speak to me now. I'm starting to work on January stuff, and we are doing a lot of equation stuff, moving into very much end of 9th grade stuff. So you Better be ready to rock and roll. Add 20, divide by 2. 60 and x is 30, right? So we got x to be 30. Letter B. Now look at that arrow. Where's that arrow pointing that angle to? 2x minus 10 is technically a interior angle, okay? It's an interior angle. Now when I look at that 3x, this one every year gets students. That 2x minus 10 and that 3x, where it's situated in an interior and an exterior like that, there's no direct relationship on there. Everything that we just walked through, there's no direct relationship there. So what can we do? And we talked about this over the last couple of days with our angles. There's no direct relationship like that. Carter?
2x minus 10 is.
Okay. What we can do is take the 3x and we can slide that on down, right?
Yeah.
Why can we slide this on down? Because why? Vertical angles. What do we know about vertical angles? They are congruent. So vertical angles are a huge tool that we'll use throughout the school year. Pythagorean theorem has been our big one. Vertical angles and linear pairs are kind of our next round of things, especially vertical angles. So we can slide that 3x down diagonal like that, and then all of a sudden, what relationship did we just create? And what do we know about same side interiors? They are supplementary. Again, more times that you write that down, it's going to finally click and stay. And it's your equation. But we had to kind of work for it just a little bit. And that vertical angles is what makes that possible. Again, that's our kind of next big tool we use a lot throughout the school year on linear pairs as well. All right, go at it. Let's solve it out. 5x minus 10. 5x in 190, right? And finish it off. Divide by 5, and what's 190 divided by 5, I heard? 38. Excuse me. X is 38, I heard. Okay. So we didn't do anything different between this one and the one above. It's just we now set the equation. We set up equations yesterday, and then we solved it out. Okay. All right. Let's take the next one, number 4. Same deal. Number 4. All right. They say that we got parallel lines here. PR and SU are parallel, and go find it out. Go put that into your picture. This brings back in our angle vocabulary, okay, our naming of angles. Go find UTQ and label that 60 correctly. That's why I've been asking you to make sure you're doing that delta math consistently so you can find UTQ. If you can't find UTQ, what have you been doing? Okay, that's where that delta math is. I know can give you some practice with that. Where's UTQ at? All right, I've got 7 areas here. Somebody, where's that 60 going? 1, 2, 3, 4, 5, 6, 7, 8. Okay, I've heard a couple different things now. So UTQ, trace it. UTQ. So where it goes at the turn, which is, yep, it is 60. So it should be going right there. Now, with that being 60 then, should be right there at UTQ. Before I go and answer anything, I'm going to go kind of what we've been doing. Fill that picture out based off that now being 60. Get those bottom 4. Play that linear and vertical angles game. That's 60, right? And what's the other 2 going to be? 120 and 120, right? They're going to be a linear pair. Now carry it up to the next 4. How are you going to carry up to the next 4? Take a vertical, sorry, not vertical. Take a corresponding. Take a same side. Take an alternate interior. I don't really care. Take one of those and carry it up to the next part, and then play that vertical linear pair game again. What do, I don't know, let's do a corresponding. If that's 60, which one's going to be 60 up there? Right, 2's going to be my 60. That's my corresponding, isn't it? So I'm going to carry that 2 as 60, and then you can play that vertical linear pair game all over again. And then the last piece is, I know it might sound juvenile, but you got to make sure you can name the angles and correctly find those out. So I'm going to take one more minute here. Make sure you go label those out correctly. So if you haven't done so yet, I know it sounds redundant, but go find me PQT and tell me what the measure is. Go find me VTU, find me what the measure is. Because as I've gone through this now many of years, that's where people get tripped up at. I don't care if you're regular geometry or geometry honors. Geometry honors, let's be honest, you all should be on top of your games. But as we just seen the last couple days, where are some of your geometry skills? They're just not strong. It's because, again, that doesn't typically happen. It's the end of the year. It just doesn't happen a lot. So that's what we're doing here, trying to beef up those geometry holes. Okay.
Oh, it said that.
Yeah, don't sign that. All right, we got PQT. What's somebody got for PQT? 60. Somebody got VTU? 120. RQT? PQO? VTS? STQ? OQR? And PQR? Ooh, I tricked you on that one, didn't I? What's that? What's that? Oh, okay. All right, we are going to pause it there. I was expecting to get through a little more of the notes today, but it went a little bit longer than I expected, so we're going to just kind of pause it there. Now, I do want you to go